Software projects fail all the time. Industry-wide stats are appalling. If you suspect your project is failing, it probably is. My name is David Wally, and I have over 40 years of coding experience with large organizations and small startups. Sadly, too much experience has been with failing projects that I joined as a coder or I was asked to evaluate or help fix. I have helped fix some projects and have started to post on GitHub the approaches and tools that helped. With some projects, the best I could do was find a specific, verifiable reason why the source code had little or no value, which helped put a stop to further losses. The contents of this video are my opinions, based on my experience and ongoing study. Borrowing from Tolstoy, well-run projects are all alike. Each failing project is failing in its own way. It may be too late for methods that work well on new projects, depending on how far gone your project is. You may require some unique approaches. If you have to decide whether to fix or abandon a project, I hope this video clarifies some options and actions. If you decide to try fixing, I offer some strategies that worked for me in this video and follow-ups. Some projects can't or shouldn't be fixed. The source code simply has less value than the cost of a rewrite from scratch. Some projects are not far gone. Perhaps training in one particular area can get your team back on track. But in my personal experience, only small projects have just one significant problem. Sometimes outsourcing is cost-effective. Without knowing anything about your project, if you already suspect it is failing, then I bet it is. And guess you have less than a 50% chance it will ever be fixed. With a strict budget, it still might be worth giving it a shot, but be a realist and expect nothing but a best effort. Before going further, make sure you've thought about the full range of your options beyond just the extremes of fix or abandon. You can abandon completely and cut your losses. Abandon, but use whatever works to help design or test a new version. You might want minimal fixes by a skeleton crew until a new version is ready, or minimal fixes and start replacing pieces one at a time. You could try fixing for a defined period of time and then reevaluate. You can try fixing, and if successful, freeze, perhaps as a free version. Or try fixing, and if successful, carry on as main product source code. Having thought about a range of possible successes, start gathering information about your project. For me, the most important information is the source code and documentation, the end product of the team's work, whether I understand it or not. The first thing I do is throw a net over the source code. Ideally, it is all kept in a version control system, such as Git, in one repository. But people forget smaller but important bits and pieces that are not kept with everything else through possible malice or just carelessness. If your source code is not in Git or equivalent system, that's a huge red flag, and you should put whatever source code you have under version control now. Documentation should be rounded up as well, but in a failing project, don't expect to find much of any value. Partly as a test of my access, I do a global search for copyright notices, and if I find one in every file created by the project team, then I allow myself a bit of optimism. I'm interested in legal ownership, but mostly I want to know what can I fix, and what was downloaded from the internet and therefore not amenable to changes. While I'm at it, I do a global search for some choice words of profanity. Doesn't solve a thing, but results have opened eyes on several occasions. Your project's problems are in your source code somewhere. So open the hood and take a peek at the engine, whether you understand it all or not. If any team members are still around, ask for a guided tour through the directories and files of the project, and take notes. Now, answer as many of the following questions as you can, as best you can. You probably do not have adequate resources to answer them all in detail. Why? How does the project fit within the larger goals of the organization? Compare the cost of complete failure with expected benefits of a fix minus its estimated future cost. What has already been lost may be a red flag, but not helpful for this calculation. The missing part of this equation is the probability of a fix, and we have more work to do. When? What deadlines exist for reports, results, and final decisions? Do you intend to create a series of deadlines, as with agile development? Sometimes the mythical and hated waterfall method makes more sense in your unique situation, but I have found most success with an approach closer to emergent design, which deserves its own video. Who? Is the team still around? Include management and clients who affect development. Who can you talk to? You may have to decide, new team or stick with the old. Or seen another way, can the people who got you into this mess get you out? If any team members are continuing on, consider the morale of the team. It's likely bad and includes regular office politics, plus accumulated stress as the project has slid downhill, and maybe in the final death spiral blame game. Of course, you should try to improve morale of any team, but some motivational events I've attended were dripping with so much irony and so ripe for insider jokes, they made things far worse. Fixing the team is great, but fixing source code must be first and foremost, and that might require stepping into the middle of old fights you know nothing about. Smooth out bad feelings where you can, but if you lose track of technical issues at the root, you end up with people who all get along great in the unemployment line. The best way to improve morale is to start fixing things and making measurable progress, even on bad days. Of course, you need to take a hard look at the abilities of the team. There may be some very capable people on the team, and if empowered, they may shine. But something has to change. So, enthusiasm for learning new things is the most important quality they can have. Rigidly clinging to a particular technology, language, framework, or practice that hasn't worked so far is an obvious red flag, but not decisive, as everyone deserves to be heard out. It is probably not your job to investigate or accuse anyone, but keep in mind, who wants to fail? Beside out-and-out sabotage, which happens, consider possible motivations like deflecting blame, saving face, proving a point, and completely understandably, just getting out of a toxic workplace without having to quit. Team members may be convinced the end is near, have no enthusiasm beyond banking a few more paychecks, and have been accomplishing nothing of value for some time. Also, who wasn't heard? Did anyone leave because they were unhappy with the technical direction of the project? Good chance she was a junior who was not listened to, was spot on, and there might even be a record of what she thought. Maybe not, but ask. If you have an opportunity to meet with individual team members, start by asking an open-ended question that tells them you are listening and far from any conclusions. So, what's really going on? Has worked well for me. Where? In-house team? Maybe just you? Or outsourced to another team or specialists? Outsourcing has potential to fix the code itself. Maybe not so much the morale of the previous team. At minimum, ask yourself who is affected, positive and negative, by a successful fix by outsiders. Of course, a fix is a good thing. Just be prepared. And of course, no one can guarantee a fix, and even if charged on a contingency basis, there's a cost to just thinking and talking about doomed projects. How? Are technical components, languages, frameworks, plugins, still viable? Are the technologies that brought the project to its current sad state to blame? Are methods and practices still viable, or are they to blame? More important, what new alternatives offer some hope? You don't have to be an expert, because somebody has to search the internet for the very latest news and opinions about the languages, frameworks, plugins, and other technologies used in the project, and it might as well be you. I Google whatever I come across in the source code or documentation, and take notes and copy URLs as I read through what I find. I then do a second search, adding the word sucks. For example, JavaScript and then JavaScript sucks. Angular and then Angular sucks. I don't have to have an opinion or agree with anything I find, but results are enlightening, even for non-coders, and sometimes go to the heart of the matter. If I know enough about the languages or technologies, I do an exhaustive review of some randomly selected source code and count defects in two broad categories, technical and cosmetic. I calculate the number of defects and divide by the number of lines sampled to get my defect rate estimate, which is lower than the actual defect rate because I can assume I missed some things. You might ask an expert to do an audit of some random code, but this assumes the expert is actually better than the team, not just better on paper, or they bring a significantly different perspective. A technical defect rate of 5% is pretty much a death sentence. A complete rewrite will probably be cheaper and certainly less risky, given that many successful projects ship with a 1.5% defect rate. There isn't a big gap between success and failure. Are you stuck with old text, old versions, with old bugs that will never be fixed? This is a downside of selecting from free libraries of other people's code. You get a feature working quickly, but code quality varies, and components may be abandoned by the author at any time. And replacing defective components with better ones is not as easy as it should be. Answering these questions and gathering any other information about the project should get you closer to a decision on the big question of abandon or fix, or find some middle ground. You might even find the cause of the failure, but it's rare that there is only one problem. It is more likely that there is a cascade of problems, each one creating others. I hope I have helped make your information gathering productive and efficient, and that it gets you closer to an answer for the big question of what to do without wasting too much more time and money. For those with a more technical background assigned to attempting a fix, I will look at some technical recommendations in the next video. Talk to you later.